Hello and welcome back to another episode of Math with Sohn. Today we are going to be looking at the coordinate plane and then finding area and perimeter of different shapes. So let's get into it. For starters, you need to know that the perimeter is adding up all the outside edges. And normally there is a formula that just isn't worth your time. It's better to just add up every single edge. And if it's on the coordinate plane, you better hope that it's going straight across like this one is, because then you could just add 1, 2, and then the other side 3, 4. And then, so if we have 2 over here and 2 over there, the top part 1, 2, 3, 4, 5, and the bottom part 5 as well. So if you add up all those, you get a perimeter of 14 units. So that's why I wrote 14U there. If it's not going straight across, like some of the other problems we will have, then you are going to have to find the distance from two slanted points. So like here, you have AB, and it's going up one and over by a certain amount. So it's got to be put into the distance formula or the Pythagorean theorem. I prefer the Pythagorean theorem. So I asked myself, what is the slope? How much did I go up? Well, I went up by 1. And I went over by 1, 2, 3, 4, 5. That is my A and my B for the Pythagorean theorem. So it's going to be 1 squared plus 5 squared equals C squared. And then we add 1 with 25, and that equals C squared. And you get 26 is equal to C squared, and I want to keep this one as the square root of 26 for C. Just like so. Okay, so we're going to have problems that will require you to do that and find the perimeter of the other parts of it too. So that's going to be happening on number 3. If we look at this one, we can find the length of AB and AC pretty easy. It went down by 1, 2, 3, 4, 5, and it went over by 1, 2, 3, 4, 5. The dilemma is that we don't know what BC is. Well, luckily, we just found the slope of this right triangle, and we got lucky that it was a right triangle, too. So we know our A and our B for our Pythagorean theorem. So we got 5 squared plus 5 squared equals C squared. 25 plus 25 equals C squared. And then you get 50. And in this case, we are going to take that 50 and we are going to square root it. And we get, if you simplify the 50, it would really be 25 times 2. And the square root of 25 is 5, so this is 5 times the square root of 2. And you could write this answer in one of two different ways. You could write it as the 5 plus this, which would be 5 plus 5, 10, plus 5 square root of 2. Or you could find the decimal of what the square root of 50 is. And if you do that, then you are going to be able to get a decimal answer, which is approximating what it actually is. And the square root of 50 is 7.07. If we added that to the 5 and the other 5, we would get the full perimeter. So that would be 17.07 units. Or you could use the more specific answer of 10 plus 5 square root of 2. Moving right along, problems may also require that we find the area. And in order to do that, we are going to need to know, what is the area formula for a triangle? Well, the area formula for a triangle is 1/2 the base times the height. And the height is this part up and down, and the base is the bottom of the triangle. And hopefully it will be a right triangle, because if it is not a right triangle, one of those two things may be difficult to figure out. So let's start with, what is the base? 1, 2, 3, 4, 5. What is the height? 1, 2, 3, 4, 5, 6. So we just plug it into the formula. 1/2 base times height. My recommendation is to multiply the base and height first, and you end up with 1/2 times 30. which is just half of 30, or 30 divided by 2, and that gets us 15. And it's not going to be 15 units, it's going to be units squared, because area is in units squared, not just units. And if that what that means is if we were to add up every single one of these squares, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, we would get 15 of them in there. And some of them would be part of a square and another part of a square, but they would all add to equal 15 units squared. Okay? So, this next problem, it says find the perimeter, but I'm also going to find the area. And I'm going to start with the easier one of the two, which is actually the area. For the area of this problem, we are going to need to figure out the base and the height. And any side can be the base or the height, but you need to be very careful on how you make your selection. And you need to be more so careful on how you choose what is going to be the base of your triangle. You would prefer, highly prefer, that the base of your triangle goes straight up and down or straight left and right. And in this case, we have this one right here. That is what I'm going to call the base of this triangle. If I were to turn it like so, then I would be able to figure out what the base is, and it would look like the bottom, and the height is, which the height is not the line, but how far does it go straight up to the opposite vertice. And in this case, it goes up by 1, 2, 3, 4, 5, 6. So that means that my height is 6. My base is the bottom, which was really kind of the side of the triangle at first, is 1, 2, 3, 4, 5, 6, 7. So we have our base and our height. We have to plug it into the 1/2 base times height formula. And again, it's way easier if you take 1/2 the base and the height and multiply those two first, because occasionally it just works out better that way. And in this case, it's no different. We get 1/2 of 42. Half of 42 is 42 divided by 2, which is 21 units squared. Okay? So that means that the area of this triangle is 21 units squared. That's the area. We're now going to find out what is the perimeter. The perimeter is going to take a bit more time because the perimeter needs to add up all 3 sides. So far, the only side I know is this one right here as 1, 2, 3, 4, 5, 6, 7. So that part's 7. But I still need to figure out what is the length of this side and what is the length of the other side. And I'm going to do that by just counting the slope for both of them to get my A, B, and C for the Pythagorean theorem. So I went up by 1, 2, and over by 1, 2, 3, 4, 5, 6. Let's count it again. Up by 1, 2, over by 1, 2, 3, 4, 5, 6. So up by 2, over by 6. My A and my B are 2 and 6. I add them together. I don't know why I wrote 36. I already squared it. So 2 squared is 4, and 6 squared is 36. We add them, we get 40. And remember that this is the c squared, so if that's the c squared, you just square root that number. The square root of 40 as a decimal is 40 square root 6.32. Okay? So that means that that side right there is 6.32. We now, I lied, is this side right here. My mistake. So we still have to find the length of this bottom side, which I just incorrectly labeled, which is going to be, again, count the slope, 1, 2, 3, 4, 5, and over by 1, 2, 3, 4, 5, 6. So it went down by 5 and to the right by 6. That is your A and your B. 5 squared, 6 squared equals c squared. 25 plus 36 equals c squared. Add them together, and we get 25 plus 36 is 61. So 61 is equal to c squared. The square root of 61 gets us our answer, and that is 7.81. So this side is 6.32. But this side down here is the 7.81. And if we want to find the perimeter, all we have to do is add up all the sides. So we already have all three sides. We just have to add them up. That is going to give us 7 plus the original 7, going around clockwise, 7.81, and 6.32. If we add up those three sides, then we get our full perimeter. And if I do that, 6.32 and then 7 gives me 21.13 units, not units squared, because perimeter is just the way around, which is how many like squares you went around it. So that's going to do it for this episode. Until next time, stay positive, and I will see everybody later.